This exercise 12.4, applications involving trig functions and graphs. Here's our first question. Ferris wheel with a radius of 35 meters rotates once every 90 seconds. Passengers enter the cabin at the loading point. You know, when you get in a Ferris wheel, they start at the bottom, right? Down here, they get in, down there, and then their position with time will slowly get higher and higher, and then they will reach a maximum height, won't they? And then they will come back down in their little cabin down to the bottom. So if that is sketched with respect to time, if we sketch the height of the cabin with respect to time, it will follow the shape of a cosine curve, but it's a negative cosine curve. So let's just write what that curve is. So question 1, we've got h as a function of time is negative 35 cos pi t over 45 plus 37. Now, where t is in seconds, right? And it's the time after leaving the lowest level on the ground. So we're going to sketch that. So we're going to sketch it for a 3-minute period after the cabin passes the loading point. Remember, the loading point is at the bottom. That's your loading point at the bottom. And we need to state the coordinates of the h-intercept. So I'll just move this up a bit. Before we sketch the actual one, we're going to build this curve up, all right? So the normal cos curve looks like this, doesn't it? The normal cos curve. That's the normal cos curve. That's y equals cos x. So before you can start sketching this, you need to know what the normal cos curve looks like. This is not the normal cos curve. This is the negative cos curve. So, for example, this is y equals cos x, but if I want y equals 35 cos x, all you do is write 35 there and negative 35 there. This isn't my curve, but that would be 35 cos. Don't worry about the pi t on 45 plus 37 yet. We're going to build that up. We've got the negative cos curve. So instead of it being up at 35, it starts on the ground like this. So this is going to be the shape of our curve. It makes sense because we're starting at the bottom point, but notice, of course, we're not starting below the ground. The whole curve gets shifted up. How high? 37 meters, okay? So instead of this being 37 down here, just remember when you get in on that thing, how many meters are you above the ground if I'm going to shift this up 37? Yeah, I'm going to be 2 meters above the ground. So we're already starting to get what our curve's going to look like. So really, I've got to add 37 to all of this, okay? So let's start doing our sketch. I'll just put this here. So, and wait, you can't see what I'm doing. So I'll have to make it a bit smaller. All right. Okay, so what we're going to do, we're going to add 37 onto each of these. So the midpoint at the moment 0, but if I add 37 onto each of these, I'm going to have 2 here. Add 37 to 35 and I'll get 72, and the midpoint is now going to be 37. All right, so I need to add 37 onto each. So what have we done? We looked at the shape of the normal cos. We put the 35 as our amplitude. Then we said, no, this is the negative cos. So negative means reflected in the x-axis, or if you've got positive 35, you've now got negative. Where you've got negative 35, you've now got positive. Then we've added the 37. All I've got to do with this pi t on 45 is to, instead of putting 2 pi, it's just changing my last number at the end, and then I'll go back and do the midway point and the quarter points, okay? So I'm going to draw that now. So we've got a negative cos curve. I'll do it nice and big. I know it says 3 minutes. Don't worry about that yet. Okay, we've got, what have we got? 2 meters. So we've got that. We've got 2. We've got 35 plus 37, 72. And the midpoint is 37. I know. See this line here? You probably want to do that dotted. Right, draw it as a dotted line. This is my h-axis with respect to t, and this will be my time down here. Sorry, it's a bit, that's 0, and this is my time there. Now let me make this bigger now. Okay, so this is what I've got so far. This you can do as a dotted line, but it's the middle point of your graph. I think it's really important that you have it there to draw it properly. All right, now, period. So we've got amplitude sorted out, we've got the shape sorted out, we've got it shifted up 37 units. Isn't period of a normal cos curve 2 pi, but it's 2 pi over the coefficient of normally what the x is. We don't have x in this case, we've got t. So it's 2 pi divided by that coefficient. I'll just write 2 pi on n or 2 pi on b, whatever the coefficient is, which is 2 pi divided by, what's the coefficient? Pi on 45. Now to divide it, no, so it's 2 pi divided by pi on 45. Isn't that 2 pi times 45 on pi? It's 2 pi on the coefficient of the x. The thing is, we don't have an x-axis now. We have a t-axis. We don't have y and x. We've got h and t instead of y and x. So it's h and t. The coefficient of the t is pi on 45. So the period will be 2 pi divided by the coefficient of normally what x is, 2 pi divided by pi on 45. So write it as a division, and when you divide by a fraction, you multiply by the reciprocal, which is what? The pi's cancel. What have I got? 90. Now, time is in what? Seconds. 90 seconds is your period. So they want, I'm going to have to redraw that now, they want a 3-minute interval, 3-minute period. Isn't that, yeah, so one period, one full curve, you've got no pi along your x-axis or t-axis anymore, is that it's the cos of pi on 45t. A simple example like that might be like this. Just watch for a second. If I say sketch y equals cos of 2 pi x, right? Just going back, just an example of this. If you go back to exercise 3C, that worksheet, question 6, we never did this question. It's a really good time now to do that question. I might say sketch y equals sine of 2 pi x, right? So this is a sine curve, is it? Right? It's a sine curve which goes like this. Okay? It's an ordinary sine curve. Okay, now, its amplitude, so we're sketching y equals sine of 2 pi x. Its amplitude is 1, no problem. But its period is not what you think. Its period is 2 pi over the coefficient of the x. Now, so 2 pi over b or 2 pi over n, whatever you want to call it. So it's 2 pi over 2 pi, which is 1. So for this curve, sketch y equals sine. So we've been sketching things like y equals sine of 2x, y equals sine x. But now sine of 2 pi x, when you do your period, 2 pi over 2 pi, you get 1. So this period is now 1. Okay? This here would be 0.5, this is 0.25, etc., 0.75. So you don't always have to have a pi along your x-axis, all right? You'll end up with ordinary numbers if the coefficient of the x has a pi in front of it, because you've got to do 2 pi divided by that, you'll lose the pi's, and you'll have ordinary numbers along your axis. So this was question 6 from exercise 3C to sketch that. So can you just look at that question? What did they ask you to sketch it between? From 0 to?
Sketch for negative y is greater than
x. All right. So if you were asked, so I've just sketched that from 0 to 1. However, in the question, you're asked to sketch it from -1 through to 2. So if you're asked to sketch it from -1 through to 2, how many periods do I have to do? You'd need 3 periods. 1 backwards one and 2 forwards ones. 2 forward ones, sorry. So you would have 1, 2. So if you were doing it from -1 to 2, it would look like this. -1. Okay? So that's what they wanted for that particular question there. Okay? So this is y equals sine of 2 pi x. Okay, so now we're going to build on that. We need 3 minutes, so I'm just going to go like this, 90 seconds, another 90 seconds. That is my H axis. This is my T axis. Notice that my actual axis is, sorry, it's not my T axis. That's 37, sorry. That's 2. That's 72. Is that right? Yeah. That's my actual axis down here. It's not this. This should be a dotted line, all right? But it's really important to put it there. Otherwise, you can't tell where anything is unless you draw that middle line. So maybe do that middle line dotted and then put your solid line down there. I've got 90 seconds. I've got 180 seconds, right? So this is time in seconds and this is height in meters. Okay, so that's your curve. So this is the curve. H equals -35 cos of pi t on 45 plus 37. Now it's a matter of reading some things off and maybe doing a few more calculations. A period of 3 minutes. So if that's 90, you know, you can put your halfway marks. That's half of the curve is up here. That's going to be 45 seconds, isn't it? And 90 and 45, that's 135 seconds and so on. Okay? And then part of that will be 22.5, etc. Okay, now it says, question B, what is the cabin's height above the ground in meters after 30 seconds? Give your answer correct to 1 decimal place. You cannot read it off. It's just too hard. All right, it's too hard to read it off. So what you've got to do is solve it. Oh, sorry, you can't read it off. You'll just substitute it into the equation. So they're asking you for part B. What are they asking you? Just to find H when T is 30. That's just a straight substitution. Just making sure that your units are correct. If you look at the question, T is the time in seconds after leaving the lowest level, so that looks fine. So you'd just be doing a substitution for part B. Are we good? So if you can do that, and then we need to do the last one after that. Yeah, H is -35 cos of pi times 30 on 45. Now, wait a minute. You're going to do this in degrees or radians? There's a pi sitting there. What do you think? I'd be putting my calculator in radians. Please put your calculator in radians. How do we know? We're talking pies. We've got pies in there. All right, so put your calculator in radians. And what do you get? Put this in brackets. Now, how are you going to know that your answer's right? It's got to make sense. So if I've got 45 seconds on my graph here, this would be 22. I reckon 30 is somewhere around here, somewhere around there. If I'm getting an answer of 54, I'm pretty happy with that answer. Look, 0 seconds, 45 seconds. A quarter of the graph is at, what's half of 22? 45, it's 22.5. So 30 seconds would be here somewhere. Getting a result of 50 something is pretty good. I'd say that that's correct. What did you get? 50 what? Point? All right, I'm going to move meters. Now I'm going to move this up. Look, 0, 45. That's for half the curve. So a quarter would be 22.5. This is about 30 here. You can't read it off. You have to substitute. So you get 54.5 meters. Okay, now part C says, after how many seconds will the cabin be 40 meters above the ground for the first time? So 40 meters above the ground, to me, that looks like slightly above 37. It should be about here. I'm guessing it's going to be around 24, 25 seconds. If I read it off the graph, let's have a look. We're not going to guess, we're going to substitute. So what we're going to do is find T when H is 40. So we substitute H is 40 into our equation. 40 equals -35 cos pi t on 45 plus 37. Now, this is now all that solving equations that we did in exercise 12.2. This is where it comes into practice. This is where it's applied. So how are you going to solve this? Do you want to take, you got some numbers on their own? What are you going to move first? The 37. So it's minus 37, isn't it? So what do you get? 40 minus 37 is negative 35 cos pi t on 45. What are you going to move next? You're going to divide by negative 35. So 40 on 37 is 3 over negative 35 equals cos of pi t on 45. Because 40 minus 37 is 3. So basically what we're solving is cos of pi t is negative 3 on 35. Now we're going to do the 3 steps like we always do. The 3 steps. This, what do? We say cos is positive or negative? Cos of pi t is that. Are we okay? So cos is negative. Cos is negative. Cos in is negative in quadrants 2 and 3. This makes sense that it's quadrants 2 and 3. You know why? Because I can see my results. Look at my curve. First quadrant, second quadrant. It's just after the 40 is just above the 37. So it is in the second quadrant. All right. Then I do acute angle pi t on 45. So I just go cos of what is negative 3. Don't put the negative in. The negative is telling you the quadrants. So the acute angle you do by doing cos to the minus 1 of 3 on 35. Do not put the negative in, please. So don't we say cos of what is the negative is for the quadrants. Cos of what is 3 on 35. So to do it, that's what you enter on your calculator. Inverse cos of 3 on 35. It should be quite small. Actually, oh no, it should be big. What did you get? Are you in radians?
Yes.
What did you get? Any more decimal places?
497.
So what have we got? 1.48
497.
dot dot dot. So keep it there. So remember, what are our steps normally? Step 1, acute angle or quadrants. Steps 1 and 2 are the acute angle and the quadrants. Step 3 and 4 is to write. Step 3 is to write your answers out. What's quadrant 2? Isn't it pi minus? And quadrant 3 is pi plus. So pi t this on 45, therefore, is pi minus this answer, 1.484976 dot dot dot. And quadrant 3 is pi plus 1.4849, etc. Now I'm going to another sheet. It's pi t on 45, just writing it again, is pi minus 1.484976 dot dot dot, comma, pi plus. Do you know why I'm writing these? Isn't quadrant 2, all right, isn't quadrant 2 normally 180 minus and quadrant 3 is 180 plus? Isn't that what it normally is? So normally these are our quadrants. Theta, 180 minus, 180 plus, 360 minus. Why am I writing pi? Because I'm in radians. Pi minus whatever your angle is, pi plus, 2 pi minus. But we know that we're in quadrants 2 and 3. So remember the steps again. The quadrants, the acute angle. That's the acute angle. Step 3 is to write out your solutions in those quadrants. That's your quadrant 2 solution. That's your quadrant 3 solution. So does anyone have a value? This is 3.14 minus 1.48, which is about 1.5 something. Pi is 3.14, remember. What is it, 1 point? I need an answer. 656616, etc. If you want, well, that's just pi t on 45, okay? And what's the other one? Pi plus?
4.62616.
Dot, dot, dot. Now, I need to get pi on its own. If that was 2t, wouldn't you divide by 2? So you just times by, so you would divide by pi on 45 or times by, don't you put the 45 up there and the pi down? So you've got this answer times 45 over pi. and then the other answer times 45 over pi. Yeah, you don't need all that there. Okay, so wouldn't the 45 go up and the pi goes down? Now look, before you worked all this out, you may have wanted to times the 45 divided by pi at that step above if you want. Okay, I know you're writing these numbers out with lots of decimal places many, many times. So what you might just want to do is pi minus the memory times 45 on pi. If you put that other number in memory, you could go pi minus that times 45 divided by pi. But please get the answer before you times by 45, because your calculator does order of operations. You need this answer. So you would go pi minus that equals times 45 on pi. Now, 45 on pi, that's about 15. I should get, what have you got? That's 23.729. That'll do. And now, just keep that one there. Can you change it to degrees and minutes, please? Because that will do time for you. So 23 seconds. Actually, now press DMS. Sorry, I know it's painful. DMS, thank goodness. They're asking to do 2 decimal places. So what's the answer? 23.73 seconds. And what would the other one be? That times 45 on pi. And 66.27 seconds. Now, let's interpret that on our graph. Remember how I said it's going to be just over 22.5 seconds? It's going to be 23 or 24 seconds. We could tell by reading it off the graph. So it's nearly 24 seconds. So this is good. Okay? I'll just bring that graph back and we'll have a look at it down here. So here's the graph. We said if that's 37, the halfway mark coming up here, and that occurs at 22.5 seconds, that the 40 would just be just after that. So it's just going to be something a bit more than 22.5 seconds. And we got 23.73 seconds. So this makes sense. Let's look at our other result. This 66.27 seconds is this result over here. No, it's not. It's this one, which is 40, just above the line. So halfway between 45 and 90, can anyone tell me what that is? 67.5, right? 40, that's at 37 meters. If I just work out where are all the quarters on my graph, I've got 0, 90, 45. Half of 45 is that, and halfway between 45 and 90 is 67.5. That's for 37 meters high. 40 meters high occurred just before that, and the answer was 66.27 seconds, and that fits in perfectly as well. All right? Like I just said, with the title questions, if you just read off your graph, you'll be able to tell if your answer's correct or not. All right? Because we knew it was going to be just a bit above 22.5, and we knew this other answer was just going to be a bit before 67.5, but the question was the first time. For after how many seconds will the cabin be 40 meters above the ground for the first time? They could ask a question now, between which times is the cabin above 40 meters? So the cabin's above 40 meters between 23.73 seconds and 66.27 seconds. Or, you know, for how long is the cabin above 60 meters? They could ask you. All right? By putting the 60 in and getting the times. Idle question. All right? So the height of water, h meters in a bay, varies over time. So we're looking at question 3. And can be modeled by a cosine function of the form h in terms of t is k cos at plus c. That is exactly the same form as the one that we were just looking at, okay? Where k, a, and c are constants and t represents the number of hours after midnight. So on a particular day off the coast of South Australia, a high tide of 4.5 meters occurred at 6 a.m. and a low tide of half a meter occurred at 12 p.m. Write a model for the height h of the water as a function of time since midnight. So just going to draw a little sketch. Maybe don't draw it yet until I'm done. All right, so what have we got? Let's read the info again. On a particular day, we've got a high tide of 4.5 meters at 6 a.m. So if this is midnight, I'll go 0. I've got 6 a.m. When was the next one? 12 p.m. That must be midday. All right. So 4.5 meters, I'll say that that is up here, 4.5. Okay. That's my height. That occurs at what time? 6 a.m. I'll call this 6 a.m. So just do a little sketch. And then we've got the low tide of 0.5 meter. So I'm going to put that down here, 0.5 meter. At what time? 12 p.m. Okay, so this is high tide, this is low tide. So what we've actually got, I wish they actually would give us more information. It is in the form of a cos curve because they told us. So it actually looks like that. And then because, so look, a cos curve goes like this, doesn't it? That's a cos curve. It goes like that. So basically from high to low, what fraction of the curve have I drawn? What? That's the whole curve. From high to low, I've drawn half the curve. So what you've got to do is assume that it will continue back up. Okay? So if half the curve happened in 6 hours, what about the other half of the curve? How many hours? Another 6. Okay, so that's what you've got to do. All right, so this would be 6 p.m. So tell me about the original. So I need to do this other half of the curve because we're starting at midnight. It should go back down. So 6 hours. So from high tide to low tide is 6 hours. So it's going to be another, you have to assume that it's a periodic function, that it's going to be another 6 hours to get back up to high tide. Okay, so that's the reason I had to go back here. Normally we do like to start on high or low tide, but they're saying take 12 midnight. Midnight has to be where you start from. All right, so are you okay with that? This is what I started with. I started up here at 4.5 meters. Low tide is the low point of your graph. So therefore, if I know that's a complete curve, this section is half my graph. Purposes, even though we only know this section from 6 to 12, we've got to assume that the whole curve is the same all the way throughout. All right, so what we did was finish the rest of it off and come back down here. Now, I do need one whole period. So where is one period on my graph? So now it says that our curve is of the form h with respect to t is k cos AT plus C. So we've got to work out the values of K, A, and C. So I'm going to move this up. Okay, let's go. Now, remember, this was the original part of the curve that I drew. I then extended it back there, and I extended it up there. Now, I only need one full curve, don't I? So where is one full curve? It said you have to start at midnight, 12 midnight. It was at 0 time. 6 hours to get up, 6 hours to get back down. Where does the full curve stop? There's one full curve. All right, now that's one full curve. So I'm not actually drawing it that way because they want 0 to be at midnight. So I've got to get rid of this. All right, and I don't need the rest of this. I don't need it. Okay. So the period is the time for one full curve. Okay, let's do something that you're comfortable with first. Could you work out can you work out what the amplitude of the curve is? How big is that wave from bottom to top? And I'm just going to draw a normal curve here. Here's my normal cos curve, right? What's the amplitude of the normal cos curve? This is y equals cos x. What's its normal amplitude? 1? -1. So it's the actual height is not 1. What's the actual height of the whole thing? It's 2. So what's the height of this one? So I've got 4.5 minus a half is 4. Do you get it? But to get the amplitude of the curve, you've got to halve that. All right, so if you look at the normal cos curve, the distance from there to there is 1, but the actual height difference of the curve is 2. So to get the amplitude, which is the number in front of the cos, you've got to divide it by 2. So I already know that k is a 2. You okay with this? So if it's 2 and the bottom of it starts at a half, what's my midway point here? Yeah, I've got to add now. So I've got a half plus 2 is 2.5, or I could have done 4.5 minus 2 is 2.5. That's my halfway point, 2.5. Does this make sense? So, sorry. Wait. So what I've got is the bottom is at half. The top is at 4.5. The way you could work out the midpoint, the middle of the graph, is to either add the 2 to the bottom or subtract it from the top. There is another way of working it out. If I said to you, what's the average between the numbers 2 and 7? How do you work out the average of 2 and 7? You add them together and divide by 2. The other way to find the midpoint is to do 0.5 plus 4.5 divided by 2. That is the other way to find the center of that curve. All right? And you get 5 over 2, which is 2.5. So there's 3 ways to find where the center of that graph is. You know what? The easiest way, I would say now, would be to add them and average them. Add them together, divide by 2, and find the average. All right? So what I've got is halfway through this curve is 2.5. That's my midpoint of my graph. So if you knew where the middle was, you can see the amplitude is from 2.5 to 5, which is 2, and it's from 2.5 down to a half, which is also 2. Now, by knowing that the middle of the graph is 2.5, which value is that? Is it the K, the A, or the C? The graph's been shifted up 2.5, so it's C. So this is what we've got so far. We know that K is 2. We know that C is 2.5. So I'm just going to write out what my graph is so far. I've got H equals 2 cos AT plus 2.5. That's what I've got so far. I have to work out what A is. Now, A's got to do with the period. Okay, now, the period is always 2 pi, I'll call it B, or 2 pi on A, because it's called A in that graph. The period of my curve is 2 pi divided by the coefficient of what's normally X, but I've got A. Can you see what the period is in terms of time on your graph? So we know the period is 2 pi on A, but if you read off the graph, so from the graph, so if you read off the graph, the period is how long for one full curve? How many hours? 12 hours. So it's also 12 hours. So if the period is 2 pi over the coefficient of that t, but the period is also 12 hours, we can equate those two and say 2 pi over A is 12 hours. So the formula for the period is 2 pi over whatever the coefficient of the x is, but in this time we've got t. But you can actually visually see that the period is the time for one full revolution, one full curve. Off the graph, the period is 12 hours. From the bottom back to the bottom, it's one full wave. How long for one full wave? It's 12 hours. So the period is 12. So therefore, if the period is 2 pi on A and the period is 12, you put them equal to each other. And solving for A, I'll put the A up there and the 12 down there. I've got 2 pi on 12 is A. So therefore, A is pi on 6. So therefore, I've now got my equation. H equals 2 cos pi on 6t plus 2.5. Didn't we have, what did we have? High tide at 6, low tide at midday, and this was midnight, 12 midnight. And that's our full curve. It's 12 hours. Okay, so let's look at our questions now. So we've got that. It says write down the rule. We've done that. And at what time does the second high tide occur? So if I continued my graph, what time would the second high tide occur if I continued it? 6 p.m. Okay. I'm going to add an extra question. So the second high tide would occur at 6 p.m. Okay, I'm going to ask you a question. And the question is going to be, at what time is the tide? So I'm going to do another question. At what times is the tide greater than, what do we do? 2 meters. So this is an extra question. At what times is the tide greater than 2 meters? All right, or greater than or equal to 2 meters. So if I look at my graph, here's my 2 meter mark. It's going to be from this time all the way here, the tide's higher than 2 meters, all the way through to this time. Now, that is before the quarter way mark. So look, I've got 0, midnight, 6 a.m. What's halfway between 0 and 6? What's halfway between 0 and 6? 3. So, girls, at 3 a.m., the tide is 2.5 meters. So what would be a good guess for when the tide's going to be 2 meters? Sometime before 3? Maybe after 2:30, 2:40, something like that, right? But definitely between 2:30 and 3, the tide is going to be 2 meters high, because the halfway point is 2.5. So what you do, you've got 0 for midnight, you've got 6, and you've got 12. That's half of the curve, 6 a.m. So a quarter of the curve is 3 a.m. Now that quarter occurs where your axis is for your graph. You know, your midway point of your graph, right? And then halfway between 6 and 12 is 9, and that occurs on there. So if I'm asking you, when is the tide? 2, that's lower than the 2.5, so it's going to be before 3 and a bit after 9, if you were to read it off the graph. I know that it'll be 2.5 meters high, the tide, at 3 a.m. and at 9 a.m. So if I want to know the times when it's 2 meters, it's going to be before 3 and it's going to be a bit after 9. Can you see it? So what we're going to do is we're going to work it out. Now, you can't just read it off the graph. You've got to work it out. So at what times is the tide greater than 2 meters? We need to work out what this time is and what this time is. And then we're going to say the tide is greater than 2 meters for any times in between that. Let's say a ship needs to sail into the harbour when the tide is 2 meters or higher. These are the types of questions you can get. All right? So what am I going to put equal to h? So 2. 2 equals 2 cos pi on 6t plus 2.5. All right, what do I do now? Yeah. Guys, I've made a mistake with my curve. It's not a cos, it is a cos curve, but it's not a normal cos curve. What's my mistake? Thank you. Because cos is like this. Isn't it the upside down version of that? It's negative. Fix it. Fix it, fix it, fix it. It's negative. So it's negative and it's negative. All right. So see how I drew my normal one? That's the normal cos curve. Yours is the upside down version of that. You got it? That's the normal cos curve. So the normal curve, the one we were looking at, was like this. It's the negative cos. So just put a negative in front. All right. So this is my curve. The 2 meters is happening in quadrant 1 and quadrant 4. And with all stations to central, cos is positive in quadrants 1 and 4. If I didn't have the negative, I was going to have all these negative values for cos is negative, and I knew I was wrong. Okay, so that's the negative cos curve. That's the ordinary cos curve. So we've got to get that right first. All right, let's start solving. What do? Take the 2.5 over. What do you got? 2 minus 2.5 is negative 2 cos pi on 6t. What's 2 minus 2.5? Negative a half. Divided by negative 2 is cos of pi 6 on t. So therefore, cos of pi 6 on t is, what's a half on 2? A half divided by 2? A quarter. Of course it is. Splitting a half into 2's. So that's all we're solving. Cos of pi 6t equals a quarter. All right, so our 3 steps, what are they? Cos is positive or negative? Cos is positive in quadrants 1 and 4. Yeah? Why? Cos of pi 6 on t is positive a quarter. This makes sense because the 2 meters is happening before the first quarter of the graph, in the first quarter of the graph. Look, a quarter, a half, 3/4, full, 1 whole part of the graph. That's how I knew I'd made the mistake. Because I knew it was in the first quarter and I was going to get cos is negative if I didn't fix that. And that didn't make sense. So, what's my next step? Acute angle pi on 6t. You have to do inverse cos of a quarter. Normally we've been practicing exact values for this, but we don't have an exact value for inverse cos of what is a quarter. So what do you get? No degrees. Go in radians. We want radians. We need radians because of the pi. See, this is really 30, but it's all in radians. So the way you do it on your calc is cos to the minus 1 of 0.25. If you are in degrees, just change to radians mode. 1.318 ... How many 8s? Etc. Now, don't go and multiply by the 6 on pi yet. You've got to do your step 1 and your step 2 and your step 3. Step 3 are your solutions. So we have to do our solutions first. Why are we saying quadrants 1 and 4? We do quadrants, then we do the acute angle, then we do the solutions. So my solutions are, what's quadrant 1? It's just the ordinary number, thank goodness. And what's quadrant 4? It's normally 360 minus, but we have to use, tell me, instead of 360, 2 pi minus that answer. ... So therefore pi on 6t is that answer, which is the same, and 2 pi minus that answer, which is anyone? So it's about 6-ish minus that, 6.28 minus, it's about 5, 4.9 something. What do we got? Comma, 4.965 ... So therefore t is, now that you've got your 2 solutions, how do you work out t? You can either divide by pi on 6 or times each of them by what? Yeah, times 6 on pi, because you see the 6 goes up there, the pi comes down. And this one also times 6 on pi. So I know that's numbers there, you've got to... So this is just the shift cos 0.25 answer, and then you'll be timesing it by 6 on pi and timesing the other one by 6 on pi. And we want our answers. Now, wait, coming back. See how this is in time and it's in hours? You have, if you want it to the nearest minute, you've got your decimal time, but we've got to change it and press the DMS button for each one. So once you've got the first one, can you give me the decimal answer? And then we're going to change it using the DMS button into time. So it should be just before 3. It should be 2 point something. Because we said just before 3 a.m. What? 2.5174. Girls, we already know that's about 2 hours 30 minutes. Can you press your DMS button? So that's that many hours, because your time is in hours. If you want that to the nearest minute, you would press your DMS button. So 2:31? 2:31? Yeah, don't worry about the minutes. It's 2 hours 31 minutes. And don't worry about the seconds. And the other one, the 4.96506 times 6 on pi. So these are in hours. Oh, give it to me as a decimal. So that should be 9.4 something. Etc. So that's just under 9.5 hours. So 9 hours and 20, is it closer to 28 or 29? But if we look at the tide, I know this is now getting into the mid. I think go for the 28 because by 29 you'll be, will it be too low? It will. Should you, oh, I'm not going to worry about the rounding of a minute. What is it? 920 what? I'll make it 9:29. Okay, so we're lucky because this started at midnight, because zero time is midnight for this question. You can take your boat through that harbour between 2:31 and 9:29. Okay? Actually, I wouldn't bank on going exactly at 9:29. The tide would have just dropped slightly below because it was 9:28 and 50 something seconds. Do you know what I mean? You'd be a few seconds off, but don't worry about that. So therefore, now looking back at the graph, 2:31 and 9:29, look at our graph. 2:31 is before 3 a.m. and 9:29 is after that 9 a.m. and the height is lower than 2.5 meters at that time. Can you see it? It's after those times. So therefore, you can, therefore we can say that the tide is greater than 2 meters between 2:31 a.m. and 9:29 a.m. We're still in a.m. All right? And that really fits in well with our graph. So the good thing about this is that you can read it off your graph. Monitoring population of penguins on Heard Island. Found that the number of penguins varies between a high of 900 at the start of the year and a low of 700 on 30th of June, and is approximated by the cosine function P equals K cos AT plus C, where T is the number of months since the start of the year. Really important to look at those units, and K, A and C are constants. They want you to sketch the graph. So you get the sketch right, everything else follows. So, what do we got? Cosine curve, they said. So what do we got? What's the high? And what's the low? All right, I know I've got this in the middle of my graph. All right? It should be dotted. I'm not going to put the dot, oh, whatever. I'm going to go 900. Don't worry about the line. Don't put the line yet, please. 9. It only goes between 900 and 700, doesn't it? And that's your low. So that's the bottom. That's not the middle of my graph. I'm going to need a pencil in a minute, a rubber. So the high is at 900. The low is at 700. That's how it goes. And then what's going to happen to it? It's going to go back up to the high. Why am I going all the way? Why don't I just draw half a curve? Because I need it to work something out, the whole curve. The period is the time for a whole curve. So that's why I have to draw a whole curve. So I've got 900 is the high, 700 is the low. That's the 6th month. They said T is the number of months since the start of the year. So what's this one going to be when it goes? Oh, I don't need this, but if it did continue, I know the population's not going to go down and back up, but I'm only drawing a curve, the whole curve, to know the period. What would this be if it did continue? 12 months. Okay, so they're saying that the population is declining, but look, I know the population's not all of a sudden going to go back up, but I have to complete a whole curve. Do you understand? All right, so even though this is really what we're just looking at, what's happening, this is the middle of the graph, and I know the axis is all the way down here, but it doesn't matter. I don't really need it. Okay, now this is the population is K cos AT plus C. I'm sure everyone could tell me where C is. Is this a cos curve? It is. It's a cos curve. All good. It's the right shape. It's not the negative cos. Come on. Normally, this is your curve. This is normally your curve. 1, -1, and 0. Good. Be careful. No, 0 is where the middle of the curve. So C is where the middle of the curve is. Well, so if I've got 900 and 700's the bottom, what's the middle? 800. So what's C? I know. Sorry. Okay. So C is 800. Guys, what's the amplitude of your curve?
100.
Good. So you've already worked out K. So, guys, C is easy. K is easy. It's the amplitude. So if you've just got your normal cos curve there, the amplitude's 1, right? The distance from there to there, even though it's 2, the difference is 200. The middle is 800. The amplitude, distance from the center up to the top, is 100. Yeah? So what else? I just have to work out A. So what's the formula? So what is the period that you can read off your graph? It's 12 months. What is the formula for the period? It's 2 pi over whatever A is. Sorry. So my period is 12 months, according to my graph. I know the formula for period is 2 pi on A, so you just put them equal to each other. So 2 pi on A equals 12. We've got the same value as before. Swap the A and the 12. 2 pi on 12 is A. So therefore A is pi on 6 again. So therefore your formula for the population is 100. Now this is a normal cos curve, so there's no negative this time. 100 cos pi on 6t plus 800. That's your equation. Sketch it for the whole year, which we did. Find the values of K, A, and C, and then it says according to the population function, how many penguins will there be on Penguin Island on the 31st of March, the 20th of June, and the 23rd of October. So they're assuming they're going back up. Now, what do those dates represent on your graph? 31st of March is, it's 3 months, isn't it? It's exactly at the middle. Because, you know, you do your graph in quarters. A quarter, a half. What date's this? That's 9 months. What date's that? So this is March. This is the 31st of March. Now, what they? Oh, and the others are harder. So 20th of June and 23rd of October are harder. So we've got to have a look at those. All right, but we can answer the first one. 31st of March is definitely at the end of 3 months. No, it is in terms of days. Oh, yeah, we can do that, actually. Why don't we do that? Great idea. All right, so this is what we're going to do. So we've got 31st of March. If you do 31, 31, 28, and 31, what does that add up to? 90. 90 out of 365. That's approximately a quarter of a year. It's slightly off. Really, the decimal that it's going to be off is not going to be much. I'm just going to go 3 months. Months since the end of the year. So what's the first one going to be then? So therefore, part C, the population on the 31st of March. You can say T is 3 months. You want to do that?
Yeah.
Yeah, so you sub T is 3. Time is 3. So P is 100 cos pi on 6 times 3 plus 800. Got it? What's pi on 6 times 3? Cos of what? What does that simplify to? Cos of pi on 2? So what do you get? What's cos of pi on 2? Go to your cos curve. Here's the cos curve. What's the cos of pi on 2? It's 0. We know this answer. We already knew that, didn't we? Because we read it off the graph. That's okay. That's good. We know that. We already read that one off the graph. It's 800. So the good thing about the graph is if you're sitting on the quarters, never do the working out. Got it? It's 800. We already knew that. We already said that before. But that's doing it mathematically. Then we want the 20th of June. So population on the 20th of June. Now you could say that 30 days has September, April, June and November. that the time is 5 2/3 months. That'll do. Just do that. Writing that as an improper fraction, isn't that 17 on 3? So the population is 100 cos pi on 6 times t, because the formula is pi on 6t. Your t is 17 on 3 plus 800. And you can just work that out. And then the last date was the 23rd of October. You could write it as the time, how many months? 10 and 23 over 31. 30 days has September. That's the actual exact fraction. 10 and 23 days out of 31.
But that would say that this 31.
For 23rd of October, population is 100 cos pi on 6 times 10 and 23 over 31 plus 800. All right, they're just approximations. Like 9. There you go. 9. We haven't completed 10 months yet. Thank you. June was correct. For the 20th of June and 838 for the 23rd of October. Having a look at the graph. 702 just before the end of June looks quite good. And a bit after 9 months to have 838 is pretty good according to your graph as well. Those fit in quite well. Okay. The other type of question could be, when is the population, you know, in which months does the population of the penguins drop below 850 or something, or drop below 750? That could be a question. So I might say during, you know, when does the population of penguins drop below 750? That's when you've got to solve for these values, and in which quadrants are you in? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. We've got a bit of time, we're going to do it. Sorry. Below 750 penguins, you would solve 750 equals 100 cos pi on 6t plus 800. Okay? We're just doing this to practice solving. All right, when does the population drop between that? So, what are you going to do first? You're going to subtract 800. Can we do it in one step? Subtract the 800 and then divide by what? 100. Did I freeze? Yeah. And then, is it a negative? Yeah. We've got negative 50 on 100 is negative a half. Negative 0.5 equals cos of pi 6 on t. Oh, this is going to be a nice one. Very nice. Cos of what is a half? This is good. Okay, so what are our steps? Step 1, which quadrants? Cos is negative in quadrants 2 and 3. That actually fits in really well with our graph. Then step 2, your acute angle pi on 6t. We say cos of what is a half? Cos of what? Isn't it cos of 60? That's pi on 3. Step 3 is to write out those solutions for quadrants 2 and 3. So how do you write out the solutions for quadrants 2 and 3? Yeah, pi minus and pi plus. Please don't forget that. So your solutions for pi on 6t are your pi minus that answer and your pi plus that answer. Well, these are looking okay. This one's actually not too bad. So what's that? Pi minus pi on 3. 1 minus a third is 2/3. 1 plus a third is 1 1/3, which is 4 pi on 3. This is good. Now how do you get t on its own? You times by 6, then you divide each of them by pi. So you go times 6 over pi, comma, 4 pi on 3 times 6 over pi. And the pi's cancel. And what have you got? 12 on 3, 4 months. So T is 4, and the other one is 8. So therefore, between 4 and 8 months, the population will be below 750. Now, how do we know that? We look at the graph. And I'll redraw the graph here, because this is what it looked like. We started at 900. I know my axis isn't that good, all right? So I've got 12 months. This is 900. This is 700. I know that's not a proper axis, all right? That's 6. 800 was there. This is 3 months at 800. And it's 9 months at 800 as well. And then if we're looking at 750, that is here. So your 750 is here, and it's from 4 months, and it's also here. And these numbers ended up being 4 and 8 on the 750 mark. So between 4 to 8 months, so what are those months? After the 4th month, January, February. During May, so basically during May through to, make sure I don't get it wrong, to the end of August. That's it. During May all the way through to August, the population of penguins will be below 750, because it's at the end of the 4th month up to the end of the 8th month, I think. Yeah. Look at this. If I put the scale, 0 is the beginning of January, 1 is the end of January, 2 is the end of February, 3 is the end of March. 4 is the end of April, 8 will be the end of the 8th month, which is August. All right?